Bad enterprise software crushes productivity with lagging inputs, while top-tier applications feel completely frictionless, fast, and magical. Applications often suffer from design debt. These are the hidden, arbitrary aesthetic choices, inconsistent buttons and duplicated font styles, that eventually break a product's usability as it scales. High-performance digital products rely on a foundation of meticulously engineered mathematical systems rather than aesthetic decoration. The invisible, rigid architecture operating just beneath the glass determines whether a workflow feels chaotic or seamless. Modern software interfaces use a framework called atomic design. The process begins by isolating the smallest indivisible variables, like a specific hex code or spacing unit, known as a design token. These tokens snap together programmatically to create more complex molecules, like a standalone button, which then combine into full structural organisms, like navigation bars and layout grids. Because these decisions are stored as platform-agnostic data, editing a single core token at the root level instantly cascades through the entire system. Developers can rebrand a global application without duplicating code. System rules dictate user psychology. Google's material design utilizes physical Z-axis elevation and tactile shadows to guide behavior, whereas Apple's human interface guidelines prioritize deference, subtle translucency, and a strict native-first layout. To maintain this level of consistency, organizations construct custom design language systems, ensuring a unified brand expression across web, mobile, and tablet interfaces. Design systems turn visual aesthetics into highly scalable data architectures, removing guesswork from the development pipeline. A flawless design system is useless if the underlying infrastructure is broken. If the server architecture causes the browser to freeze, the interface becomes a barrier. Engineers track this responsiveness through a metric called Interaction to Next Paint, or INP. It captures the exact delay between a user's action and the screen's visual response. Traditional single-page applications often degrade this metric by triggering massive hydration waterfalls. These downloads block the browser's main thread, leaving the application visually rendered but unresponsive to input. Teams can address this by housing a modular monolith inside a single repository, or by breaking the application into decentralized micro-frontends, allowing isolated teams to deploy updates independently. The architecture of the frontend should mirror the communication structure of the engineering team. When these systems misalign, the user experience fractures. Island architecture shifts the paradigm, treating most of a web page as static HTML, rendering only specific, isolated zones as active JavaScript environments. These interactive islands hydrate completely independently. A heavy component loads in the background without ever freezing the primary navigation. Concepts like server components and resumability push this further by moving heavy data fetching logic back to the server, ensuring the browser handles minimal code. Modern development prioritizes extreme subtraction, achieving near-instant performance by delivering the functional depth of a massive app while shipping almost no code. The traditional static page model is dying, replaced by software that stops passively displaying data and begins autonomously making decisions. As systems become proactive, human-in-the-loop design becomes essential. Oversight is the critical requirement for AI agent workflows that handle high-stakes execution. The interface must clearly communicate the AI's confidence level and explain its proposed actions through patterns like the Agentic approval queue. Adaptive product cards and global command palettes move the user away from manual, nested menu diving and toward intent-driven, search-first interactions. As AI handles execution, the primary role of the interface shifts toward establishing human trust by making complex logic explainable. Proactive AI interfaces rely on the same atomic tokens and optimized island architectures that keep data moving instantly today. Standardizing tokens and isolating code allows the interface to recede, eventually reaching a state where only the execution of intent remains. These invisible mathematical structures now govern how we interact with every screen and service in our daily lives. Are we merely designing interfaces, or are we engineering the invisible systems that shape how human beings think, decide, and work?